All right, guys, for those of you who are watching the video at home, I don't know why, but it was not recording initially. The answer key is posted online. If you have any questions with regards to questions 1, 2, 3, 4, 5, please ask me and or Kristen. So yeah. Okay, so the next 5 questions is going to be either 1 population hypotheses, 2 population hypotheses, 1 population confidence interval, or 2 population confidence interval. I'm going to give everyone time to work on it. So let's read it together and then I'll start the timer. So number 6. Many years ago, Gallup surveyed adult women in the U.S. and asked if they self-identify as a crazy cat lady. And I want to emphasize that I mean that in a good way. I consider myself a crazy cat lady, so... They found 40% of women did self-identify as such. It is suspected that this percentage has increased in 2023. Gallup gathered a random sample of 1,200 adult U.S. women and found that 504 self-identify as a crazy cat lady. And the following steps test the claim that at a 10% level of significance, the population proportion of women who self-identify as a crazy cat lady is more than 40%. All right, so I'm going to set the timer for 10 minutes. If you're watching this video at home, please utilize this 10 minutes to try the problem yourself before you go to the answers. I can't believe it wasn't recording. I hit record. I know I hit record. I wonder if I accidentally stopped it.
And now it's not recording?
No, it's recording now because it has a little red button.
Oh, I was able to post the form.
I'm going to Google if there's a way to pause it. If you want to check your work along the way, Kristen does have an answer key. So that way you're not like 20 steps deep and then you got something wrong. Yeah. Oh, okay, this is interesting. So they said to there's how many parts? A, B, C, D, E, F, G. There's parts G. How far did you guys get?
I got to F.
To F, okay.
I got to D.
D? Anyone else? How far did you get?
The next one. F.
Okay, you guys want to just start going through it? Okay, I am a little bit worried on time, so I think for this one we could start going through it. Okay. So, state the null hypothesis, alternative, and what type of test this is. Okay, well, actually, before we even do all of that, this is not a question being asked of you, but in general, 1 population, 2 populations, hypothesis test, or confidence interval. 1 population. Hypothesis test. Good. And so that way you know where to look on your formula sheet. Okay. All right, so let's state the null hypothesis. The null hypothesis is that P equals what? 0.40. Good. The alternative is that P is going to be something compared to that 40%, but what about it? Greater than. Good. And we got that from right here. More than 40%. All right. Test the claim at a 10% level of significance that the population proportion of women who self-identify as a crazy cat lady is more than 40%. Left-tailed, right-tailed, two-tailed? Right-tailed.
I told these girls that just left the
Right-tailed.
Whoops.
It's okay. We all make mistakes.
I was
All
like,
right.
whoa, 0.40, that's a lot. This is 0.04, I told them.
That's A-okay. Sample proportion. How do we set that up? Let's see. So we know it's P hat. So they got a random sample of 1,200, of which how many identified as crazy cat lady? 504. So 504 out of 1,200. Feel free to use your calculators. I believe that is 0.42. All right. Standard error. Again, look to your formula sheet. So the standard error is equal to the square root of P times 1 minus P all over N. Just remember, be careful. That's why I said a lot of students make a mistake. They'll accidentally plug in P hat instead of P. But it wants P, which is 0.40 or 0.4 if anyone wrote just 0.4. Times 1 minus 0.40 all over, what was N? 1,200, good. And that should give you 0.014. Any questions there? Part D, find the z-score, which again, formula, P hat minus P all over the standard error. You have all three pieces of information, so it's a matter of substituting it in and then using your calculator. So P hat, we said was 0.42, minus P, we said was 0.40, over the standard error, we said that was 0.014. Plugging that in and rounding to 3 decimal places is 1.429. Okay, so now we can compute the p-value. So p-value equals the normal CDF. Is this problem doing a negative infinity or positive infinity?
Positive.
Positive, good. And it's positive for several reasons. Because it's a right-tailed test, it's greater than, and because our z-score is positive. So it is 1.429, which was our z-score, to positive infinity, 0 and 1. Using your calculators, that should give you 0.077, or if you want to go ahead and write it in percentage form, 7.7%. Any questions there? Okay, so now what do we do with the null and alternative hypotheses and why? I like to start off with the why part. Well, our p-value is 7.7%. What was the level of significance we're comparing it to? 10%. Be careful. Most of the time it's 5, but it's not always 5. So look back to the question if you need to. And the question said 10%. And 7.7% is less than 10%, right? Therefore, it is statistically significant. Which means that we reject the null and support the alternative. hypotheses. Lastly, we state our conclusion in the context of the problem. Remember, that requires 3 pieces. What was your significance level? Your sample data supports or does not support the claim, and then restate the claim. So, at the 10% significance level, the sample data support the claim. And we're supporting the claim because we're supporting the alternative hypothesis. So supports the claim that, and again, look back to the problem if you need to. What was the claim? So it's right here. The claim is that the population proportion of women who self-identify as a crazy cat lady is more than 40%. So that the population proportion of women who self-identify as a crazy cat lady is more than 40%. Any questions? Okay. Pencil sharpener. I don't see one in here. There might be one out there though. Okay. Let's read number 7 together and then I'll set a timer for you guys to work on it. So number 7. In a random sample of 5,230 cat owners, if you can't tell, I was in a very pet mood when I wrote this. So in a random sample of 5,230 cat owners, 3,828 claim their cat as indoor only. Using the sample data, construct a 99% confidence interval estimate of the true proportion of cat owners who has their cat be indoor only pets. All right. I'm going to set the time.
Is it recording right now?
Yes. Okay, y'all, welcome back. Let's go over question 7 from bonus part B. So, part A, determine the sample proportion. So, sample we know is p hat, sample proportion. And it was out of 5,230 cat owners, 3,828 say their cat is indoor only. This rounds to 0.732. Next, we need to satisfy the conditions for approximate normality, in which if you had p, you would use p, but we don't. So you do n times p hat and n times 1 minus p hat. Where n is the sample size, 5,230, times p hat, we just found 0.732. So this will give you, for this one, I'm just going to round to the nearest whole number. I know we've been doing like 3 decimals, but I'm just going to do nearest whole number here, because why not? So 3,828.
Do whatever we want.
Yes. And I do specify on the exam where to round.
Okay.
Yeah. And this one's 5,230 times 1 minus 0.732, which I'm getting 1,402. Both of these are greater than 10. So are the conditions met? Yes.
Before you move on, would you take off points if we inserted like exactly how you did, like the 5,230 in parentheses times 0.732, but we added the decimal after the the whole number after the 1,000, would you take off points for that?
Where at?
Cause like when I inserted it, it gave me 3,828.36.
Oh yeah, that's perfect.
Oh, okay.
Yeah, and that actually would technically be correct because I said around to 3 decimal places.
Yeah, that's.
I just got lazy for. I was like, oh, so many numbers. Okay. Next is calculate the estimated standard error. So, let me change the color here. Estimated standard error is equal to, from your formula sheet. Oh, I should have asked you this from the beginning because it determines where we go in our formula sheet. What type of problem is this, like in general?
Confidence interval.
And how many populations?
One.
Good. Is one population confidence interval. So that's the portion that you are using from your formula sheet. Okay. So from your formula sheet, okay, you would see that it is p hat times 1 minus p hat all over n, which is the square root of, so this time we are using p hat, so that's 0.732 times 1 minus 0.732 all over n, which the sample size was 5,230. Rounding to 3 decimal places is 0.006. Next, we find the margin of error, which again, from your formula sheet, you would see that that's the critical value times the estimated standard error. From your formula sheet, at the 99% confidence level, what's the critical value? 2.576. Good. Times the estimated standard error you just found in the previous step is 0.006. That should give you 0.015.
Yeah.
Cool. This is a typo. This should say 99%, not 95. So 99%. Find the confidence interval. We know that is p hat minus e and p hat plus e, which we have those values. P hat is 0.732 minus 0.015. And then separately from that, you do 0.732 plus 0.015. This results in 0.717 and 0.747.
I have a question.
Yes.
Does the order really matter?
Yes.
It does?
Yes. So you do the subtraction first and then the addition second.
Okay.
Lower and then higher.
Thank you.
And lastly, part F, interpretation. We are 99% confident that the true population proportion of cat owners who have their cat be indoor only is between 71.7% and 74.7%. Any questions? All right, well, good job. We have now done one population hypothesis test, one population confidence interval. Let's see what, yes, question?
Do we need to have population proportion or can we just put proportion?
If you don't do population proportion, if you say, you have to say proportion. You would say that the confidence that the proportion of all cat owners, you'd have to then use that keyword all.
Mm,
So that way we know it's the entire population.
okay.
Yeah.
Thank you.
Yeah, 'cause I copied the claim from up above,
Mm-hmm.
like literally word for word, and it doesn't say all or population. So if something like that comes up, then we know that we have to add in all.
Oh yeah, I see what you're saying. Yeah, I prefer to see the word all. Because that's the whole point of doing this. Because all we know is the sample proportion, right? That's all we know. And the whole point of doing a confidence interval is to figure out the population proportion. That's the whole point of doing the confidence interval.
I guess my question, maybe it's the same for you, is that if on the exam we come across that and it says the true proportion,
Mm-hmm.
and we don't add in the true population, or we don't say the true the true proportion of all cat owners,
Mm-hmm.
are we gonna get marked down because we didn't
Potentially.
freely add those in?
Yeah, potentially.
Sneaky.
Yeah. So I was the word true that could stay or go, but just include population proportion. Because again, that's the whole point of doing a confidence interval. The end goal of a confidence interval is to figure out the range within a range between where the population proportion can be found. All right. Good questions, guys. Number 8. Gallup conducted a national poll asking, do you have a cat? It is found that more women than men have a cat for adults in the U.S. You want to know if a similar result holds for the city of Anaheim. You claim that the proportion of women who have a cat is more than the proportion of men who have a cat in Anaheim. You gather a random sample of 500 women and find 370 have a cat. You gather a random sample of 500 men and find 360 have a cat. And when we're saying random samples, we're assuming they're taken from Anaheim. I should have included that. Use the sample data and the steps below to test your claim at the 5% significance level. All right, I'm going to set my timer. I'm going to try to ensure my... So, what is the null and alternative hypotheses?
P1 equals P2.
P1 equals P2 is the null, and what's the alternative?
P1 is greater than P2.
All right, and how did you know it was greater than?
Because women who have a cat is more than the proportion of men.
Perfect. All right, it's not asking for it, but is it right-tailed, left-tailed, two-tailed?
Right.
Right-tailed. And once again, I forgot to ask, but is this one or two populations? Two populations. And is it a hypothesis test or confidence interval?
Hypothesis.
Good. So when you're looking at your formula sheet, this is the chapter 7 portion. Good. All right, calculate the difference in observed sample proportions. So we know that means you're doing P1 hat minus P2 hat, right? That's the difference in sample proportions. But you need P1 hat and P2 hat. You may have done something like Kristen had done on the board. So you already know what your P1 hat and P2 hat are, and you'll just plug it in. So that's something you would have done on the side. Or you could do it at this point here. It's totally up to you. So P1 hat, that will be for the women, just because the women came first. And it was 370 out of 500 have a cat, which is 0.74. And then P2 hat is the men, because the men were talked about second. And that'll be 360 out of 500, which is 0.72. So now that we have the sample proportions for the women and the men, we could plug it in to calculate their difference, which is 0.74 minus 0.72, which gives you 0.02. Part C, calculate the pooled proportion, which that'll be P bar equals, look to your formula sheet, there's a formula, x1 plus x2 over N1 plus N2. So you add together how many women and how many men have a cat, divided by how many women and how many men were surveyed. So let's see here. 370 women have a cat. That's what the question was talking about, right? How many people have a cat?
Yes.
Yeah, okay. Plus 360 men have a cat over 500 women were surveyed and 500 men were surveyed. This should give you 0.73. All right, now we could calculate the standard error. Which is equal to the square root of, look to your formula sheet, it's p bar times 1 minus p bar over n sub 1 plus p bar times 1 minus p bar all over n sub 2. And that will give you the square root of 0.73 times 1 minus 0.73 over 500 plus 0.73 times 1 minus 0.73 over 500 again. And it's just coincidence that those were exactly the same because they just happened to select the same amount of women and same amount of men as their sample size. Once you plug that into your calculator, you get 0.028. Questions there? All right, z-score.
Real quick.
Yeah.
Is everybody comfortable entering all that underneath the square root in your calculator?
Yeah.
Okay.
So for the z-score, remember we are going to do p1 hat minus p2 hat all over the standard error. All right, that's the formula for when it's two populations. You already did p1 hat minus p2 hat. We did that up here. So we just substitute that in. That was 0.02. And then in the previous step, we just found the standard error, 0.028. That gives us 0.714. Or sorry, did I go too fast? Did I hear a little longer? Okay, so find the p-value. The p-value is equal to normal CDF. Are we doing negative infinity or positive infinity?
Positive.
Positive, good, because of the right-tailed test. So you start with the z-score, the 0.714 to positive infinity, 0 and 1, which is 0.238, or as a percentage, 23.8%. All right, so what do we do with the null and alternative hypotheses? Well, our p-value, which is 23.8%, what was our level of significance?
5%.
5%. Is that less than 5%?
No.
No, it is not. Therefore, is it statistically significant or not?
No.
It's not. Good. So not statistically significant. Which means we do not reject the null. And we do not support the alternative hypotheses. Any questions there? All right, so lastly, our overall conclusion. At the 5% significance level, the sample data did not support the claim that, let me look back to see what it was. You claim that the proportion of women who have a cat is more than the proportion of men who have a cat in Anaheim. So support the claim that the proportion of women who have a cat is more than the proportion of men who have a cat in Anaheim. Any questions? Okay, let's keep going. Number 9. A survey on pet ownership was given to U.S. adults in 2015 and in 2020. In 2015, 645 of the 1,022 randomly selected adults reported that vet care is too expensive. In 2020, 673 of the 1,140 randomly selected adults reported that vet care is too expensive. Tests claim that the proportion of U.S. adults who think vet care is too expensive in 2015 is different from the proportion of U.S. adults who think vet care is too expensive in 2020. Use a 10% significance level. All right, 10 minutes. Oh, actually, I'm going to do 13 minutes again, like last time, because it's a little bit lengthier. All right, so what is the null and alternative hypotheses? So let's start with the null. Oh, but back up. I keep forgetting. 1 or 2 populations. 2. Hypotheses test or confidence interval. Oops, I started combining that. 2 populations. Hypotheses test. Cool. Okay, so what is the null?
P1 plus P2.
Perfect. What is the alternative?
That's where I was confused. I don't know if it's less than or not
Well,
equal
I
to.
thought it was not equal to, because it said different from.
Yes, that's the key phrase.
Yeah, that's what I
Different
mean.
from. Different from is the does not equals. It's different.
I was going for less than.
We don't. So it would explicitly say less than
Yeah.
or fewer than. It would say something like that to clearly indicate that it's less. But in this case, it's not indicating either way. It just says different, and that's why we use that. Left-tailed, two-tailed, right-tailed?
Two-tailed.
Two-tailed. I said that a little bit out of order, but two-tailed test. All right. Difference in sample proportions. We know that's P1 hat minus P2 hat. We need to calculate both of those unless you did it off to the side, like the way that Kristen likes to do it, which is beautifully organized. So P1 hat. So in the last example, we were comparing women and men. This time we're actually comparing different years. We're comparing 2015 and 2020. So in 2015, 645 out of the 1,022, that shall give you 0.631. And then in 2020, that's our P2 hat, That'll be 673 out of the 1,140. Think vet care is too expensive, which is 0.590. So now that we have our sample proportions, we can plug them in and calculate it. So 0.631 minus 0.590, that's 0.041. Calculate the pooled proportion. Feel free to use your formula sheet. The pooled proportion is x1 plus x2 over n1 plus n2. So in 2015, how many felt it was too expensive? 645 plus, compared to 2020, it was 673 out of 1,022 and 1,140. I believe that's 1318 out of 2162, which gives us 0.610. All right, so then we can calculate the standard error. Which recall for two populations is p bar times 1 minus p bar over n sub 1 plus p bar times 1 minus p bar over n sub 2. So this will give you 0.610 times 1 minus 0.610 over the first sample size, 1,022, plus 0.610 times 1 minus 0.610 over the second sample size, 1,140. And we're taking the square root of that entirety, which should give you 0.021. All right. On a roll, let's next calculate the z-score, which is going to be the difference of your sample proportions over the standard error. You already found the difference of your sample proportions from part J. We had gotten that to be, why did it start with J? Oh, weird. It started with I and then J. Okay, so part J, 0.041. Over the standard error, 0.021, which I believe that will result in 1.952.
Yeah.
Okay. Let me just throw out a question at you. Is this unusual?
No.
No, good, because not your z-score is not more than 2. All right. So we can find the p-value. Be careful here. This is a two-tailed test. So what do you have to do with the normal CDF?
2 times normal CDF.
Good. It's 2 times the normal CDF because it was a two-tailed test. So 2 times the normal CDF. Are we working with negative infinity or positive infinity? Positive. Now in this case, the reason why we know it's positive is because our z-score was positive. So positive infinity. So 1.925, 1.952 to infinity, 0 and 1. Some of you may do it all in one go. Some of you may break it down by first doing the normal CDF, rounding it, and then multiplying it by 2. If I don't specify which way to do it, then either way is acceptable. In the end, I got 0.051.
Yeah.
Okay. All right. So what do we say about our null and, this is the same thing as 5.1%, right? 5.1%. Okay, so our p-value, which is 5.1%, what was our significance level?
10%.
10. All right, sweet. So 5.1% is less than 10%. Therefore, it is statistically significant. That means we reject the null and support the alternative. Hypotheses. And lastly, state the final conclusion. At the 10% significance level, the sample data support the claim that, and then feel free to look back to the problem itself if you forgot what the claim was, but the claim was the proportion of U.S. adults who think vet care is too expensive in 2015 is different from the proportion, that's okay, of U.S. adults who think vet care is too expensive in 2020. Any questions? All right, guys, we're almost there. Just one left. A study asked participants to describe their level of concern that their pet would need vet care in the near future. Of 502 women, 104 responded they were concerned that their pet would need vet care in the near future. Of 496 men, 85 responded that they were concerned that their pet would need vet care in the near future. Construct a 95% confidence interval to estimate the difference between the proportion of women and the proportion of men who are worried their pet would need vet care soon. Okay, so find the sample proportions and sample difference. All right, so the sample proportions we know is going to be P1 hat and P2 hat. P1 hat will be the women, P2 hat will be the men. So P1 hat, of 502 women, 104 were concerned their pet would need veterinarian care soon, which I believe is 0.207. And then the sample proportion of the men, of 496 men, 85 reported that they were concerned. So that'd be 0.171. And then we need to find their sample difference. So we subtract those two values, which is, I believe, 0.036.
Yes.
Okay. All right. Next, find, oh, I should have backed up. I'm going way too fast just because we're short on time. This is two populations, correct?
Yes.
And hypothesis or confidence?
Confidence.
Confidence interval, good. So when you're looking to your cheat sheet, this is from chapter 7 under the confidence interval. So then the estimated standard error, if you look to your formula sheet, is the square root of P1 hat times 1 minus P1 hat all over n sub 1 plus P2 hat times 1 minus P2 hat all over n sub 2. So this is 0.207 times 1 minus 0.207 all over the sample size for the women, which was 502, plus 0.171 times 1 minus 0.171 all over the sample size for the men, which was 496. Plugging all that into your calculator is 0.025. All right, then we can find the margin of error, which is your z-score, or the critical value, times the p1 hat times 1 minus p1 hat all over n sub 1 plus p2 hat times 1 minus p2 hat all over n sub 2, which luckily that huge chunk in the root we already found. So use your table from your cheat sheet, your formula sheet, to determine your critical value z, and you correspond it to the level of confidence, which is 95%. And you'll find from that table that for 95%, your z value is 1.960. Okay. Times this whole guy here you just did in the previous step. That's the estimated standard error. So you don't have to redo all of that. Just substitute in what you found, which was 0.025. This is 0.049.
I have a question, like,
Yes.
based on the formula sheet, because I think I know what I did wrong.
Uh-huh.
So it says, this part, I right away assumed it was P1 minus P2, so I would put 0.036. Right here, I got confused on this part.
Okay, I probably have something written differently right there. Here's this part faster. Okay. So.
That's so annoying.
I know. So let me get it. Okay, so for that one, which one are you looking at? Let me see.
The margin of error, this one, specifically this one.
Margin of
Professor
error.
Moss, it's not the p-bar because we don't have a p-bar, huh?
No, it's-
Correct, not for the confidence interval.
Okay,
Yeah, on the formula
It's a
sheet,
Z
we're not
times-
using p-bar here.
okay.
Up here.
Okay, thanks.
All right. So then for the confidence interval, again, feel free to use your formula sheet. P1 hat minus P2 hat. So you're taking the sample difference, subtracting the margin of error. Then you take the sample difference and add the margin of error. Well, the sample difference, this portion here, the P1 hat minus P2 hat, we already did. The P1 hat minus P2 hat, we already did here and got 0.036. So I'm going to substitute that in. So you're taking the sample difference, 0.036, subtracting the margin of error, 0.049. And then similarly, we add those two values together, 0.036 plus 0.049. And I believe you get negative 0.013 and separately from that 0.085. So what is this telling us? This is telling us that we are 95% confident that the difference between that's the key thing. We're finding the difference between these populations. The difference between the proportion of women and the proportion of men who are worried their pets will need vet care soon is between -1.3% and 8.5%.